All right. Hi. I am going over this check your readiness. So just trying to review some big ideas from geometry that you learned a year or two ago using a little bit of trig. So sine, cosine, and tangent. All right. So looking at number 1, we're using triangle ABC to answer the questions. So which equations are true? So we have these cosine equations and then these sine equations. So if you remember those trig ratios, the sine of an angle is equal to its opposite leg over the hypotenuse. So if we're looking at angle A, here's angle A. This is the opposite leg, and this is the adjacent leg. And then 5, the longest side, the side that is across from the right angle, that's the hypotenuse. All right, so if we want to know about the sine of angle A, it looks like opposite has a length of 3, hypotenuse 5. So I think this first one, the sine of A, is equal to 3/5. 3 is the opposite, 5 is the hypotenuse. And then cosine. The cosine of an angle is equal to the adjacent leg over the hypotenuse. So again, for angle A, the adjacent leg has a length of 4, and so 4/5 would be the cosine of angle A. So cosine 4/5, there we go. Okay. All right. In the next one, finding x in the right triangle. So remember, in the right triangle, there's something called the Pythagorean theorem, and that says that when you square the legs of a right triangle and add them together, you get the square of the hypotenuse. So we usually call the legs A and B, and the hypotenuse is C. And so it's that A squared plus B squared equals C squared. And so I'm just realizing I didn't bring my calculator. I have to go get one. But so we have A is 4, B is X, and C is 6. So 4 squared plus X squared equals 6 squared. So let's see, 16 plus X squared equals 36. So that means X squared must equal 20, 36 minus 16. I'm actually not going to use a calculator. So if X squared is equal to 20, then X is equal to, it's exactly the square root of 20. I'm just going to leave it like that. You could punch it into the calculator if you wanted to. All right. Next. Okay, so we have a picture and we have to select the true statements. Okay, so we have a circle O and it looks like it has a diameter of AB. Okay, so the ratio of the circumference of the circle to the length of AB is pi over 2. So the circumference of the circle all the way around compared to the diameter, the length of AB, is pi over 2. The ratio of the circumference of the circle to the length of segment OA is pi over 2. Okay, so circumference to diameter. I remember that there is something about circumference and diameter having to do with pi. And I remember a formula for for circumference that involved pi. So circumference is equal to 2 pi times the radius. Well, 2 of the radius is the diameter, so the circumference is equal to pi times the diameter. Those would be equivalent. So if I were to talk about the ratio of the circumference to the length of segment AB, which is the diameter, I think I would use this equation, okay? So if I were to say, okay, if C is equal to pi divided by the diameter, then the ratio of circumference to diameter has to equal pi. The ratio of circumference to the length of segment AB is pi over 2. It's not pi over 2, it's just pi, so not that one. And then the ratio of the circumference of the circle to the length of segment OA. So OA would be a radius, is pi over 2. So that would make me want to think about this formula. If I change that by dividing by the radius, I get C over R equals 2 pi. Not the same as pi over 2. So it's not this one. The ratio of the circumference of the circle to the length of segment AB is pi. Well, I actually already found that right here. This is true. I'm going to circle that. And then I'm just going to check the last one as well. The ratio of the circumference of the circle to the length of segment OA is pi. And that's this one that I already checked. The circumference to OA, which is a radius, it's actually equal to 2 pi. So anyways, I just generated all of these from those two formulas that you have learned in the past for circumference. So C is the only correct response there. Next, a car wheel has a radius of 1 foot. Which of these statements are true? Select all that apply. Okay, so the radius is 1 foot. I'm going to draw that. That's a pretty good circle. The radius from the center to the edge is 1 foot. Okay, in one revolution of the wheel, the car travels pi feet. So one revolution would again be the circumference. Now, this is a radius, so circumference is equal to 2 pi times the radius. So 2 pi times 1 is 2 pi, not pi, so not A. Okay? Next, in one revolution of the wheel, the car travels 2 pi feet. Yes, because 2 pi times 1 is equal to 2 pi. So yes for B. C, in 1/4 revolution of the wheel, the car travels pi over 2 feet. Okay, let's look at that. So we know it's 2 pi in a full revolution. So 2 pi in a full revolution, but let's divide it by 4 because we want to know 1/4 of a revolution. And so I can simplify this. 2 goes into itself once and into 4 twice, and I do get pi over 2. So looks like C is a yes. Next, a truck whose wheels have a radius of 1.5 feet advances 1.5 times as far as the car per wheel revolution. So with a radius of 1 foot, that car travels 2 pi. But 1.5 feet, that would be 2 times pi times 1.5. That's the radius. That is 1.5 as far as if the radius were just 1. So yes to D. And then finally, a truck whose wheels have a radius of 1.5 feet advances 1.5 squared times as far as the car per wheel revolution. This cannot be true. We just found it to be 1.5 times, not 1.5 squared times. Okay, so just B, C, and D. And we're on the home stretch. Just a couple more problems. I love number 5. So in this next unit, we're going to not spend a ton of time reviewing sine, cosine, tangent ratios. We're going to be using them, though, to find some particular values. So this is a big idea. It says, explain why the equation cosine A equals sine C is valid. Okay? Well, let's look at the cosine of angle A. So here's angle A. Okay? Cosine is equal to the adjacent leg, right here, over the hypotenuse. Okay? So the cosine of A equals, well, this adjacent leg is AB. And this hypotenuse is AC. Okay, that's the cosine of A. Now let's compare that to the sine of C. So here's angle C. And as we stated earlier, well, I'll just rewrite it. The cosine is the ratio adjacent over hypotenuse. Sine is the ratio of opposite over hypotenuse. Okay? Well, for angle C, AB is actually the opposite, and this is still the hypotenuse. And so what it comes down to is that the sine, I'm running out of ink, the sine of angle C is also equal to AB over AC. And so I think we can say that this equation is valid because they are both equal to AB over AC. So the cosine of A equals the sine of C because both equal AB over AC. All right. Okay, and then number 6. So number 6, you might not remember this as much from geometry because it was kind of at the end of the year, and probably some classes probably had more time to talk about radians than other classes. So a real quick thing about radians. So a radian on a circle is basically related to its circumference when the radius is 1. Okay? So if this circle has a radius of 1, then that means its circumference, the distance all the way around, starting here at 0 and traveling around the circle, is 2 pi. So all the way around would be 2 pi, which means from A just to B, starting here where I put the 0, from A just to B would be a distance of pi. So with those as kind of your indicators, you should be able to figure out where to put these points, knowing that you're traveling in this direction. Okay? All right. So point C, where AOC measures pi over 2, or half of pi. So if the semicircle is pi, then halfway, so straight up from here, is where I would put point C. So that this is basically a 90-degree angle. Okay? And then 3 pi over 2 would be 3 of these. So 1, 2, and then the third one would be right here, straight down from there. So this would be another, right angle right there. And so it looks like this is point D. Okay, point E. where AOE, so from here to O to wherever E is pi over 4, or 1/4 of pi. So remembering that C is at pi over 2, or 1/2 of pi, this would be half of that. So half of this distance right here, so halfway, I'd say about there, is going to be point E, straight through the middle. And then finally 5 pi over 4, we could also think of that as 5/4 of pi. So the pi over 4, that's 1/4 of pi. So we can kind of use that as our guide until we get to 5 of them. So here we go, 1, 2, and then halfway is 3, 4, and then halfway from B to D would be 5/4. So right there is where we should put point F. All right, so that concludes the check your readiness ideas that I'm hoping throughout, like practicing on the worksheet by yourself and then watching the video, explaining it a little bit. I'm hoping that these are things that you're recalling, that you did learn in geometry, and we will expand more on this when I return, which will be tomorrow.